Just let me know when you need me to.
Now we are live.
Great. Hey everyone, this is Dhruv from Team HackerEarth. Today we have a slightly more fun video that we are going to take you through. It is with HackAtom India. It's a hackathon that we conducted with Cosmos Persistence and Tendermint, a blockchain hackathon, and probably one of the bigger ones that we have done this year on HackerEarth as well. We had over 1,200 registered participants, who came up with great solutions that pertain to the Cosmos ecosystem. Of these solutions, we had four final winners, three top winners, as well as one winner in the community engagement side, who came up with something really cool to help engage with the community as well. Without further ado, I'd like to pass the reins on to Gokul, who is from Team Fusion Ledger, which had finished first in this hackathon. So over to you, Gokul.
For the introduction. It's really an exciting moment for Fusion Ledger framework, and personally for me, ever since I started the journey with Cosmos and with Tendermint. My journey with Tendermint started quite early in 2018, where I initially explored the synergy between Ethermint and Ethereum. And it was really fascinating, an idea to pour TVM into a new chain. And then I learned more about the Internet of Chains concept from Cosmos. And I've been really excited to see the growth of the Cosmos ever since. And today, when I am presenting to you the solution from Fusion Ledger built on Cosmos SDK and Cosmos WebAssembly with integration to Polkadot, especially to Polkadot's Substrate framework for IBC, inter-blockchain communication, and Polkadot's Gossamer, Polkadot's Go host for interoperability. So this is what I would like to present today. Please let me share my screen. Dhruv, could you please confirm you can see my screen? Dhruv, is my screen visible?
Yes, it is.
Okay, so let me take you to I will first navigate you to the code base. So, you can visit the code base. This is created as I created based on my inspiration from Cosmosm. So I created it as a fork from Cosmosm. So if you go to Cosmos WebAssembly, I was really fascinated to see the Cosmos WebAssembly smart contracts. Initially, when I did the fork on the while the hackathon was going, it had only some of these contracts were not there in the initial fork. So when I did the fork, I have written with and let me take you to my code base. So I've used primarily Cosmos atomic cost CW20 atomic swap, CW20 base, CW20 escrow, and CW721 base, CW3 multi-sig, and I also added an innovation called a random oracle. So these are the contracts. Let me get back to the presentation, and then I just wanted to show you the code base of this Fusion Ledger Moornet. So when you see, let me give you an introduction to Moornet. So in Moornet is the particular solution by our Fusion Ledger. Okay, Fusion Ledger is the framework. What is Fusion Ledger? Fusion Ledger is a concept to bring in cyber physical systems together. It is a kind of fusion between data, devices in the digital domain. So that is so Fusion Culture creates a framework for integration and interoperability between chains, between data and devices. So this is the framework on which I've created Moornet. And there are applications of Moornet are built on Cosmos SDK. I was really excited to see the new cool tools from Cosmos SDK like Scaffold and Starport. It made my life very easy. So if you come to Moornet, in Moornet you can see all the Moornet apps are built using Cosmos SDK. So Moornet, there is a basic application, there is a payment application, there is a DAO and a stream, a money streaming concept. This is one of the focus area of Moornet. So if you come to the Moor app, the basic app, this app is deployed using a tool called Scaffold. It was really fun to deploy this app, write the basic features. So you can see, normally it takes a lot of time to create the Cosmos SDK based app, but here it was really easy for me. So this is the first app, Moor app. So the one other app I would like to show you is the Moor DAO. This app is based on Tendermint, so Ethermint. So this provides an interoperability with Ethereum. So if you come here, you can see that this is referred from the Argon chain. Argon is one of the prominent DAO built on Ethereum. So this is doing an interoperability between Ethermint and Cosmos through Ethermint, and this DAO is what I'm using in Moornet. And then I've created a stream, a money streaming application. This is the concept. I've created a money streaming app. This app is again based on Tendermint. I've used a Starport for creating it. And this app will be realizing a concept known as money streaming. Streaming money is a concept which is really very promising. Lightning Network is one of the first implementations, and now there are some implementations going on in the world of Web3. And I'm actually planning to work more on the area of money streaming for the Moornet. One of the focus area will be money streaming. And if you come to the payment, this is where I've integrated something known as Gossamer. Gossamer is the Polkadot's Go implementation. So you can see that I've used Gossamer. Gossamer is developed by, Gossamer is developed by ChainSafe. So it is actually a kind of implementation on the top of, okay, let me get back. So it is a kind of implementation of Polkadot on Go. So this is what I am integrating in the Moornet application. So now let me take you back to the presentation. So applications are on Cosmos SDK, and I've integrated Cosmos SDK with a distributed randomness. It's called DRAND. So the DRAND is the random oracle which I'm using in Cosmos, the Cosmos WebAssembly contracts. And as I mentioned, Cosmos SDK with Polkadot Gossamer, and the token. So the applications are on Cosmos SDK, and the tokens are created using Cosmos. So this is the architecture. First, we'll have applications. So the apps will be on Cosmos SDK with one sample integration with Polkadot Gossamer, and there is another one through Ethermint DAO. So there is a DAO, there is a streaming app, and there is a payment app. Okay, now coming to the Cosmos WebAssembly. So here I have done the interoperability between Cosmos WebAssembly and a substrate palette for inter-blockchain communication. So this is based on Polkadot's concept of substrates. you create substrate parachains and relay chains. So this is what I have created here. I've created Cosmos with Substrate IBC, and I'm also using a Polkadot JS client, WebAssembly client, to interact with the Cosmos contracts. So this is, if you can see the architecture, this is how Moornet is distributed. On one side, we have all the business logic written in the tokenomics written in Cosmos, and it is leveraging the Substrate IBC palette for the consensus. It is actually using Polkadot's Grandpa consensus, and it is also having a Substrate client to interact with the tokens. So, and the other side, we have Cosmos SDK based applications, which are connecting with the Polkadot host and the Polkadot JS client. So the final ecosystem will be like, it is using the security and the fault tolerance and the scalability of Cosmos, and it is using the different consensus algorithms and different infrastructures of Polkadot, right? So the highlights of the applications are Polkadot. The apps are built on Starport. They are deployed using Scaffold tool. The DAO is built using Ethermint. The Moornet Pay connects to Polkadot Gossamer, and these are the contracts used. CW3 fixed multi-signature, CW20 atomic swap, CW20 ERC 777, and I'm also using an random oracle. This is based on CW3 random oracle. Okay, so Moornet apps you have seen. The basic app is for workflow. MoorPay is for micropayment. MoorStream is for money streaming, and MoorDAO is for communities. So the focus on interoperability is achieved using the interaction between Cosmos with the inter-blockchain communication IBC protocol, with a configurable consensus algorithm. Even though it is using Grandpa consensus of Polkadot, it is possible to use other consensus of Polkadot in this. So when we get back to the code base, you can see the Substrate client. You can see the Substrate client here. Substrate Lite client is used here. You can find the client details here, and how the client uses Grandpa consensus. What is the storage? You can find here the sample contracts. You can find here the state and the message and the details. You can find here. And when you come to the consensus part, this the consensus which is used, it is implementing the standard IBC protocol. So it is based on the ICS specification, and this is inspired from the you can look at the ICS standard, and when you come here, this is using Grandpa. Grandpa is the consensus. You can find all the details of the consensus state and the state machine here, and it is using the Grandpa consensus here. When you come here, you can see how it is defining the consensus state and the client state, and the details of the client are written in this. This is the IBC client. So here, you are invoking both the client state and the consensus state, and this client is verifying the connection, and it is also, so you define the client consensus state and the connection state, both are verified here. Okay, and so in that aspect, the Substrate IBC consensus, right, is a giant step towards. It has two palettes. If you look at, there is a template palette I've used. So this particular Substrate palette can be deployed on the relay chains of Polkadot, but here my focus is to use them along with the Cosmos with the focus on interoperability. So when you come to the contracts, you can see the one of the interesting contract I'm using here is the random oracle. So the random oracle contract, if you see here, this contract is based on DRAND. it is a distributed randomness that it is using. So this randomness is having a lot of applications in the, when you look at the Cosmos WebAssembly contracts. One of the application would be, I can use this source of randomness. It's a verified randomness. When I'm using this randomness inside the block, I'll be able to, so this is how I'm using the randomness. This randomness could be used for verifying the time-based transaction. That is one of the focus area. I basically, even though I've defined money streaming in the Cosmos SDK app, I would like to use in a kind of token known as bonding curve. So one of the next step for me is to write a CW20 based bonding curve, okay, and bonding curve token, which is using the random oracle. I'm also planning to use this random oracle in other creating a RAND DAO in Cosmos. So here, in the atomic swap, when you're swapping between two tokens here, I'm planning to use this random oracle. So this is about the contracts, Moornet contracts, and we have seen the Polkadot JS client is actually implementing the Polkadot's WASM provider. So it is also having an lib2b2b based WASM extension, but this WASM provider is actually a very useful tool to bring in WebAssembly based interoperability for in the Polkadot client side. And it would be so, as I have shown you in the architecture, the main plan is to leverage the business logic and the application logic. That I mean the tokenomics on the Cosmos and the application logic on Cosmos SDK will be exposed through the Polkadot based consensus in the Substrate IBC, and the Polkadot client, Gossamer client would be the Gossamer client would be the Polkadot Gossamer client will expose the Cosmos SDK application. So this is the architecture, and this is the code walkthrough I wanted to share in this presentation. Over to Dhruv and Cosmos India. And once again, it is really a pleasure and privilege to do an application focusing on interoperability in the Cosmos ecosystem. And I was really excited to see the promises of interoperability between Cosmos and Polkadot. I also found ways in which I found many other use cases and reference implementations in Ethermint, but as a new experiment I wanted to try with Polkadot. That's why I focused on Cosmos Polkadot interoperability more than the Ethermint side. I'm also seeing more security focused interoperability implementations are coming on other, like somebody is trying between Cosmos and other blockchains. But this is hopefully my focus is to build more and more logic and more applications on Cosmos and deploy them into Polkadot and other chains in the following phases, and focus on money focused applications like micropayments, money streaming for money streaming. I would like to use it for use cases like pensions and other use cases like salary distribution, micropayments, etc. So that is the focus of Moornet built on Fusion Ledger framework. I know I have some more time left.
Gokul, if you want to share anything, you can go further.
Sure. So let me take you through the how I set up the code, and let me give you more information about the Substrate IBC. And let me come take you back to my screen. So when you, for example, I've touched upon the Substrate IBC, right? So let me take you through the IBC protocol and the ICS standard. So when you look at the ICS standard, see the very important standard which are used here. This is called, see, let me first introduce ICS, which is the base of this interoperability. So, hope you can see my screen. So ICS is the interchain specification from Cosmos, and there is a specification ICS 10 for the Grandpa client, which is the base of this integration between Cosmos and Polkadot. So this specification describes a verification for a blockchain using Grandpa consensus. Grandpa is what is Grandpa consensus? Grandpa is ghost-based recursive ancestor deriving prefix agreement. It's a finality gadget. Finality gadget is a concept we say in consensus, right? That is will be used by Polkadot relay chain. So Grandpa is used by Polkadot's specific. Polkadot has two kind of chain, relay chain and the para chain. So this is used by the relay chain. It is right now having a REST implementation, and as part of the Substrate, blockchains built using Substrate will use Grandpa as the finality gadget. So blockchain with Grandpa, you can integrate with interface with replicated state machines over IBC. So this is the possibility. This is just it's a revolutionary possibility through this ICS standard, right? So not only with whichever replicated state machines will be using IBC, they can use it. So as you have seen in our code base, you have seen how I am using the Substrate IBC palette. So this is using. So when you come here, you can see I am using Grandpa here, and this is based on the ICS 10. And let me also take you through the details of Polkadot Gossamer. Polkadot Gossamer is actually a Go implementation of the Polkadot host. Gossamer is used to build and run node for different blockchain protocols which are compatible with Polkadot ecosystem. So the core of the Polkadot host is the WASM runtime. So that is why I have chosen this for the interoperability. Apart from the Substrate IBC palette, I've chosen Gossamer because of the reason is it is the way it has it has the interface with a WebAssembly runtime. So Gossamer includes node implementation for major blockchains within the Polkadot ecosystem. So we need so to set up Gossamer, you need more than Go 1.4. So the base is from ChainSafe. I am also looking at another implementation from ChainSafe called ChainBridge, which will offer more possibilities of interoperability between Ethereum, Polkadot, and Cosmos. And so you can build the Gossamer through make command, and then you can run your Gossamer node, and you can start your node. You can, in the future, like there is a work in progress feature called Gossamer node of Polkadot. You can run the Gossamer as a Gossamer node, and yeah, these are other features available. So this is basically the Gossamer Gossamer's all configurations and def properties configurations you can find here, right? And So you can find all the properties of Gossamer here in this part. And let me take you back to, let me take you back to the chain, how the, so Gossamer, it is actually, there are two chain implementations. One is the Gossamer node implementation and the Gossamer node implementation. These are the two node implementations. So essentially, here you can find this Polkadot host will function as the host infrastructure, and this will act, this is the WebAssembly client from Polkadot. So this is the host, the chain, Polkadot's node infrastructure, which I'm using for Cosmos SDK apps. And this is also having a WebAssembly interface, so I can possibly use it along with the Cosmos. But at the moment, I'm using it with the Cosmos SDK apps. And Polkadot JS client, I'm using as the interface to interact with the Cosmos SDK apps. And this is the Substrate client, and this is the Substrate consensus. So hope this presentation. So as you can see here, I have a lot more work to be done in it comes to one of the, to build it or to present this to the market. So my immediate focus would be to roll out one application, especially money streaming application, leveraging Cosmos contracts and Cosmos SDK applications with the interface to Substrate consensus. I mean the Grandpa consensus on IBC on site Substrate palette, and using Polkadot Gossamer. This is the immediate focus. And then I'm planning to add a bonding curve into this, and to add more tokens and more application logic into it. Thank you so much for giving this time once again to
Gokul.
hackers.
Thank you, Gokul, for your useful information. Can you briefly share your experience at HackAtom India, and how do you see Cosmos ecosystem growing in India?
See, I am really delighted to be part of the hackathons in HackerEarth, because HackerEarth is a very thriving community. I find a lot of enthusiastic developers and projects and organizations doing hackathons. That's the reason I come back again and again to participate in hackathons on HackerEarth. So I've been familiar about HackerEarth for a long time now. So it's a great place to hack. And about Cosmos India, and especially the leadership that Persistence is providing to Cosmos India, it's tremendous. The knowledge and the thought leadership, especially from Abhitej and others on, I think Shreyansh and others on the Cosmos innovations, like the video sessions from the Cosmos India and Ethan Frey on latest additions to Cosmos was really enlightening and exciting. And what I find is there are really good quality developers getting on board on Cosmos. And so I believe there is good knowledge about cryptocurrencies, crypto economics, blockchain technology in the Cosmos India ecosystem, and generally in Cosmos, right? There's and if you look at globally, Cosmos has really outstanding Rust and Go programmers, and that's really fascinating to be part of this. Once during this hackathon, I got an opportunity to interact with Ethan when I had some Ethan Frey, or when I had some doubts on IBC, and I also got a chance to join a discussion group on interblockchain communication. So it's a great learning experience to be part of Cosmos India, but I believe I have a long way to go. Especially, I would like to contribute more on the ICS standards. I would like to contribute more ideas on Cosmos tokens and interchain specifications. I believe this is like a great encouragement for me to contribute deeper. I always got fascinated by the vision of Cosmos to integrate different blockchain ecosystems. And now I believe it is getting right support from the world of other blockchains like Polkadot, Enigma, and others. So I believe this is just we are in the crossroads, or we are in the early phase of a great revolution ahead. Looking forward to more and more support, guidance, and inspiration from Cosmos India and Cosmos Universe.
Thank you, Gokul, for the encouragement, and we will look forward and keep on trying new stuff and bring value to our community.
Yeah, yeah.
And
And one more thing I would like to add, the experience of Cosmos is really nice. The experience design, the the packaging of Cosmos application, whether I'm using Starport or Scaffold, it was really great experience. Unlike I'm not comparing with some other chain, but the packaging of products and platforms in Cosmos is really outstanding. It is like it makes developer life really easy, and so we can focus on more complex things and save a lot of time in basic stuff. This is what I really enjoy as a developer working on Cosmos tooling.
thank you, Gokul. And on the behalf of Persistence, Cosmos, and Cosmos India, I would like to congratulate you for the Gaia Award.
It's an honor, it's a pleasure and privilege. I would like to be part of the family of the ecosystem and do more on the tooling side, cryptography side, and the consensus side.
Thank you, Gokul.
Thank you.
So, so now I would like to call upon Prashant of Multiverse, and they have built a real estate decentralized exchange, and they have won the Cosmonaut Prize in this HackAtom India. So now I would like to hand over the mic to Prashant.
Can you guys please hear me?
Yes, sure, we can hear you.
Yeah, we are really excited to won this Cosmos Hackathon prizes. So initially, now we are introducing our team, and then we'll go after our application walkthrough. So as we are a team, Sai Krishna, me, and Ravali, we work for this application Dharani, and we had a 2.5 years experience on Cosmos network, and we developed many applications on the Cosmos. And recently we got GOG winner also, and now we participated in this, and here also we won the prize. Next, we'll give you the walkthrough of our application. Initially, we'll give the what technologies we'll use and what is actually the application and how we implemented using the Cosmos, and we'll explain the code walkthrough here, and we'll give you the demo and what are the future plans. Uh, Let me share the screen.
Prashant, after you share your screen, please let me know. I'll enable it on the screen.
Yes, can you see my screen? Hello.
Yes, we can see your screen, Prashant.
Yeah, yeah. Thank you. Yeah, this is our application structure. We build this application structure using the start port. By using that application, we can easily generate the Cosmos application framework. This is our app file. We imported all modules of Cosmos network, Cosmos SDK, and this is my module. Dharani is the module we implemented here, and this is a type of property having the ID and how much area it has, and who is the owner of this property, and where that property is located, and what type of property is that, and from where this property became, I mean which property is became, that property ID will place here, and what is the cost of that property of per square feet. So we'll give you the complete code flow from the client. We'll explain the messages, all over things here. Initially, the person will add the property here using this message. This is the person address who is adding that property, how much area it has, and where property. Using this message, the person will do the transaction of adding that property. After that, after adding this property, he can create a sell order from this property. Here we can concentrate on, we can sell the whole complete property, or we can sell the fractional of this property. Yeah, using this message, we can create a sell order here. This is a property owner address and which property you want to sell and how much area you want to sell that existing property area, and how much cost you want to put per square feet. Using this message, we can create a order, selling order, and another person will come and buy those property using this message. Here is the person address, and this is which property ID you want to buy and how much area you want to buy. And these are all the message structures, and we'll explain the client module. These are all the client transaction modules. Using here, you can add the properties. Using this add command, you can add the properties, and you can buy the property using this command. You have to give some flags of how much property you want to buy and from which property you want to buy, etc. These client modules are normal, everyone can use this. We implemented CLI module and REST module here to use APIs or you can use CLI, and we'll give and explain handlers. This is a handler of handle add property. Here we'll check whether the property has already has or not. We'll manage the properties based on the IDs. Each and every property will increment the number of IDs. Based on that IDs, we can query or we can manage we can edit or anything based on this property. So here initially I want to add the property. So initially I don't have any properties in the chain. So I got 0 here. Get properties. From this properties count, I will get property ID. From those property ID, we'll create a new property structure here. The property ID, how much area he has, and who is the owner, where that property is located, and what type of property. So initially the reference property ID is name, and there is no then because he is not selling any property, actually we want to add the property in our plot. After that, we'll store this property in our keeper. In our keeper, we'll get the store and the property key base will create a property keys in order to store the key value pair. Based on the ID, we'll get the key, and to the key we store the property. After setting this property in the keeper, and we'll also increment the properties count because each property will have a unique property ID, so that we are incrementing the property count here. This is a handler of adding the property. This all are the events will return in a result of the transaction.
I guess there was a problem with Prashant. So now we will just go ahead, and I would like to call upon Arpit of Dev Demons, and I'll hand over the mic to him.
Yeah, so Arpit, can you hear me? So first of all, I guess
Yes, I can. Yes, I can.
Hello.
yeah.
Yeah. Yeah.
So should I present?
No, let me. I have it.
Okay, okay.
Yeah. Is it visible?
Uh, yeah.
So I, Arpit Srivastava, Aman Raj, and Ashutosh Singh. We are undergraduates from Triple IT Vadodara, and we have built an app to conduct online exams without internet. We have used uh, tech stack of uh, Cosmos Ethermint to build upon our app, and where on the blockchain side we have Web3.js and Cosmos Ethermint and IPFS. For IPFS, where there is a use, we will come to it, and our backend technologies consisted of MongoDB, Node.js, Twilio, SMS API 2. In the front end, we use React.js, and in the mobile app was built on Flutter. So I will just give a brief working of our hack. Yeah, is the scene visible?
Yes, yes.
During COVID-19, many exams globally. Is audio clear?
Yeah, yeah.
Okay. During COVID-19, many exams globally are being conducted online, but there are various connectivity issues due to poor internet, as internet speeds globally vary drastically from as high as 120 Mbps in South Korea to as low as 10 Mbps in Bangladesh. Besides, universities also have to spend a huge amount on setting up a good cloud infrastructure. So we will be solving this using blockchain and SMS. 10 to 15 days before the exam, the professor will have to upload his question paper on our portal, which will then be encrypted and stored. Then 3 to 5 days before the exam, the student will download the encrypted question paper so that he has no connectivity issues during the exam. Now, 5 minutes before the exam, the professor will SMS the encryption key to the students to unlock the paper. Now, the student will attempt the exam and submit his PDF of answer sheet to our offline mobile app. Now, the app will create a SHA-256 hash of the answer sheet and SMS it to our Twilio number, where the hash will be stored on the blockchain if timely submitted. Now, sometime later, when student has no connectivity issues, he can upload the answer sheet, and we will compare the uploaded file's hash with the SMS sent hash to check that the student has not tampered with the file after the deadline of the exam. The professor will have to register his exams on our portal and upload his question paper, and then he will choose a deadline. Now, we will deploy a smart contract on Ethermint from the professor's wallet to the Ethermint chain. And on the backend, a create force function of Solidity will be called. Now, after some time, the professor will receive his link to the AES encrypted question paper stored on IP address and also the encryption key. Yeah, as we can see here. And the professor has also received a subject ID, which is in fact the address of the course, smart contract of course, which has been deployed on Ethermint. The professor will now send the link of the AES encrypted question paper. Now we can see that here the create code function was called when the professor had deployed the address. This will create a code instance of a code contract on the Ethermint chain. Yeah. Now let us move to another section.
Now, 5 minutes before the exam, the professor will send the SMS password of the AES encrypted file to the students so that the mobile app can unlock the paper and they can begin with the exam. I have already downloaded the encrypted file and I have the password saved on the clipboard, and I will decrypt this. The file has been decrypted and saved. Now for the answer sheet submission, the students will submit his PDF to the app where a SHA-256 of the file will be generated and an SMS to a Twilio phone number will be sent, which will store the hash on blockchain. I will choose the decrypted file, which is manual.pdf, enter the subject ID, and generate. A hash has been generated. Now I will send an SMS to our course instructor. The SMS has been sent. Now this person will repeat the same process for the rest of the exams. Now when all the exams have ended, the student will upload his answer sheets collectively using the mobile app. I will choose a file and upload. The file is now being uploaded. The file has now uploaded.
As we know, the file hash has been stored on the Ethermint chain corresponding to the student's public address if the student had submitted before the deadline. So now we will check the hash, previously stored hash, and compare it with the hash of the finally uploaded file. And if both the hashes match, then we will download the answer sheet and give it to the professor, as it ensures that answer sheet has not been tampered with after the deadline. Let us see the answer sheet. Yeah, that was our idea. What we basically decided was, since in the pandemic, many
students. I hope आप लोग ठीक होंगे.
yeah, the pandemic, many online exams are being conducted, but many students are facing problem giving it. So what we decided is to use proof of existence on blockchain, and thought of migrating the online, making it possible for the students to give online exams without internet too. So the basic idea was to use some cryptographic hashing and encryption too to make it possible. What we did was that the student can be allowed to download the question paper beforehand. But beforehand, let us say 10 days before or 5 days before, when he has sufficient internet. Uh, and after he has downloaded, he won't be able to open that question paper since that would be encrypted. Now, after just before the exam, the student will be able to receive an encryption key via SMS, and this encryption key will unlock the question paper, which and so he can start with the exam. After it, we what we he can do is, for submission part, let us say deadline of the exam is 2 hours before the exam start. After the exam starts, then he will upload the file to our mobile app, and the mobile app will create a SHA-256 hash, and the mobile app will SMS that hash to our Twilio number, and that Twilio number is connected to cloud, and the cloud will store the SHA-256 hash of the file that is being sent, corresponding to the public key of the student. Then what we will do is, since this has been stored, so now student has sufficient time to upload the answer sheet whenever he can find time and internet connectivity. So let us say 3 to 5 days before, when he has sufficient internet, or any time, then he can just upload the answer sheet to IPFS. Our mobile app will do it to IPFS. So the answer sheet will be uploaded to IPFS, and the answer sheet will be sent to the professor. Before sending it to the professor, we will check whether the uploaded files hash and the previously submitted hash via SMS to Twilio, they both match or not. And if they match, it means the file has not been tampered with after the deadline. Else, it has been tampered with after the deadline. So if that hashes match, then we will send it to the professor, or we will not send it to the professor. And we use Ethermint, and it's significant. Ethermint and it significantly reduced our submission block time. And for this, what we did is that we deployed Ethermint on cloud, and created a code for. What we did that we created cloud, and what we did that we created we allotted generating registering of students possible by creating a possible private key generation, that each student was allotted a private key, and he would use it to submit to the exam. Here is our Solidity contract that we deployed on that. And like, if any professor is coming to our portal to start with the exam, then he will then this Solidity contract create course function will be called, and the smart contract of that course will be deployed. In this smart contract, in this smart contract, as we can see, that the hash of the file will be stored corresponding to the sender's public key, so which will be used for fetching it later. Our server side was built on Node.js, and we have set up our upload. We have made a possible uploading the question paper to IPFS, and we made possible. We allotted some ether to we allotted some ether to each public key that is being created, so that we allotted some ether to each public key that is being created, a private key that is being created, so that the student, whenever he submits the exam, then the transaction cost will be deducted from it. Yeah, as we can see that this is the deploy contract function, which will be called whenever the professor creates the exam. Yeah, and this function is this function slash submit will be called whenever the private key course address and file hash will be created whenever it will be called using Twilio API. The Twilio API whenever receives the SMS, it will redirect to this platform so that the hash can be submitted to our platform. That's it from our side.
Um, Thank you, Arpit and Aman, for the useful information. I'm sure that our community was able to learn more about your project. So, I would also like to congratulate you on the behalf of Persistence, Cosmos, and Cosmos India for the Special Mention Award.
Thank you, sir.
Okay, thanks a lot.
And now I would like to hand over the mic to Prashant to continue his project.
Yeah, hi guys. Because of internet issue, I left the meeting. Let me share my screen again. Can you see my screen? Hello? Hello? Yeah, okay. I stopped while walkthroughing this handler module. We have three types of messages. First one is add property, sell property, buy property. This Dharani project is used to tokenize our real estate module. So you can from here you can add your property, sell the property, you can buy your properties. Based on this message you can add the property, this message can sell the property, you can this message you can buy the property. We'll explain all these handler functionalities one by one. If I want to add my property into our website, you have to interact with the app layer using this command, add command. You have to give the area location details, and from there you can you will come to this handler add property function. Here that message values got. Here I'll manage the property based on the IDs. Each property will consist as each property ID. To generate the property ID uniquely, will maintain the property count. That is here PC. Initially, we don't have any properties in our chain, so I got the property count 0 here. Based on the 0 property count, I'll generate a ID of the property ID. That is property ID I got here. Like for example, property 1. Let me consider. Based on that property 1 ID, I'll generate a property structure. I'll have to give this property ID and this area from who's the owner of the property and where that property is located and what type of property. Initially, I don't have any reference property because I'm newly creating this property here. So this is the per square feet cost. Initially, we don't have any cost here. Based on these properties, we'll create the property structure, and I have to store this property in a keeper with respect to key value pair. Here we'll get the keeper store here. Based on this property ID will generate a key, and to this key will store the property value here. After storing this property, and I have to increment the property count because because we are maintaining the property IDs uniquely. So after storing this property, incrementing this property count uh, after storing the successful property, will give the events in a result. This handler is completed for adding the property in our platform. So for example, if I add the 100 square feet of property added here, and I want to sell 50 square feet of property of mine property. For that, I have to use this sell command. For that, you need to give the property ID, area, how much you want to sell, and what is the price of per square feet, and which property ID. All those things you have to give. Based on these values, you have to build the message and need to broadcast. After that, you will come to here. Here you got the message values. Now we are checking whether that property is already really existed or not. So here we'll get the property based on this ID from the keeper store. If that property is there, we'll get the property. If property is nil, we'll give an error, and I have to sell my own property because that is only the ownership. So here the property owner should be equals to this message signer. If that is not equal, will give an error unauthorized, and I have to check whether the filling area should be less than the actual property area. So here we are checking the condition. This is error, and if all conditions are successful, we can sell property using this value. For each property, as I told, I maintain the unique ID. So I have to maintain this unique ID. I have to get the property ID first. Before that, I have to get the properties count. Initially, now here I will get the properties count 2 here, because after storing this property, we incremented the properties count. Here we'll get the properties count. So initially 0 will increment it to 1. Here we'll get the 1 property ID. Based on this property count, we'll generate again property ID. This property ID will assign to the new property, and that new property area, how much you want to sell, and me, only the owner of that property, and the property location. These are all came from this property, from the keeper only. And this property type is sell, not owned, because while adding the property is the type is owned, because I'm not selling this property. Here I want to sell the property. To differentiate those kind of properties, we are maintaining the type sell here, and this property is the reference property ID of this new property. This is the reference property. The old property ID is here, and the per square feet of cost that we got from the message. Using these values, we'll create the new property, and we have to subtract the area of selling property of actual property. If I have actual property area is 100, and I want to sell the 50 square feet of property here, I have to subtract and update that property also. So the property of area is area minus the selling area, and that have to be set in the keeper here, and the new selling property also has to set here. After setting this properties in a keeper, and I have to increment the properties count here, and the new property ID, owner, all these events will be given in a result of successful transaction. So adding property and selling property is completed. And if I want to buy property, which already ready to save. For that, I have to use this command, buy command. For this, you need to give these details, which property you want to buy and how much area you want to buy. With these details, you need to build the message of buy property, and you have to broadcast. While you broadcasting, that will be come to this handler, this handle buy property. Here you got the buy property message, and again I am checking whether that sold property is there or not based on this message ID. If that property, if I got the nil, and I'll return the error, and whether that property's type is sell or not. If that is owned, we cannot buy that property. If that is sell only, we can buy the property. We are checking that condition also. And the area of this buying area should not be greater than the selling area. That condition also we are checking here, and we are calculating the amount per square feet cost into how much area we want to buy. That will be calculated here. If the selling property area is 50, if I want to buy only 20 square feet of area of that property, and 20 into per square feet amount, if it is 1 unit, 20 into 1, 20 units of amount, that amount will be calculated. If the buyer don't have that amount, then we'll give an error. If he has sufficient balance, we'll subtract the amount of the buyer account, and that same amount will be added to that property owner. After that, we have to create a new property based on the count. We'll get a count and create a property ID. Based on these values, we'll again create the property type, and again we have to reduce the selling area properties of buying area property. We'll set that property also, and we'll sell this buy property again here, and we incremented the property count, and the property buying owner and the property IDs of events will be written in a successful transaction. These are all the handlers. This is a flow of this client to messages, client to message modules to handlers to keeper flow of Cosmos framework. And we used Cosmos version of 0.34.4. Cosmos version is also available, 0.3.739 also available, but those version of Cosmos SDK is not support to use the IBC transaction, and that are not standardized. So in this 0.34 version, it is able to do interchain blockchain transaction, IBC transaction. In future, we will implement those also. So we used this version of Cosmos, and the Tendermint, which is suitable for Cosmos version, is 0.33.4, and we use those types of versions here. And I would like to give a demo of our application. Dharani is our project. So this is initially the login. If you have an account, you can directly enter the password to unlock and directly go to the dashboard. Otherwise, if you want to create new account, you just click here. Username is as soon as you created the account, you will get an account address and account public key. and the account seed, and you have to store these seeds to restore your account. uh, After storing these details, you will directly redirect to the dashboard of Dharani. So this is the account information here, and this is the property information will be here. So initially I don't have any balance in the account. This is my account address, and I want to add the property. uh, Before that, if you want to do anything in the chain, you need to have a balance in the chain. So that I am requesting free tokens from the faucet. We build a faucet also. So I got 500 sent. This is our denum which we used in our application. Sent. I received the 500 tokens here. So I want to add the property. This is my account name. This is the account password. Default values already set here. I want to add 100 square feet of area at Hyderabad. The property is added successfully. Here you can see my property. That property ID is prop 43, and the owner is me. That is my account address, SCX. The location is Hyderabad, and the area is 100. So you can see the properties which are ready to sell in the marketplace. These all properties are ready to sell. That property ID, who was that owner, and where that property is located, how much area is ready to buy, and how much cost per square feet. If you want to buy, you have to click here. Before that, I would like to sell my this 100 square feet of property. I have 100 square feet of property, but I want to sell only 50 square feet of property. Per square feet value is 1. Let me give 1 cent per square feet. 50 square feet, 50 cents. So let me create sell order here. So my property area is subtracted to 50 square feet here, and that 50 square feet of property will be listed in the marketplace. My account address is SCX lost. The property, this is SCX. Property ID is newly generated 44, located in Hyderabad, and 50 square feet of area is ready to buy, and cost per square feet is 1. Put it. That's it. That is the creating of buy order. So if I want to buy the property of property 3, which is there here, and 3 square feet of area, per square feet cost is 5. So I want to buy this one. Before that, let me check.
Hey Prashant,
Yeah,
in the
yeah,
interest of time, it will be great if you can conclude your project.
yeah, sure. Just one thing is there. Yeah, if I want to buy this, I need to mention 3. So 3 into 5, 15 cents will be deducted from here. This is a demo of our application, and future will implement this application into not only for this real estate tokenization, we will also implement NFT as company shares, etc. Yeah, thank you.
Thank you, Prashant, for your presentation. I'm sure that our community was able to learn more about your project. And on the behalf of Persistence Cosmos and Cosmos India. I would like to congratulate you for the Cosmonaut prize. I just wanted to ask that how was your experience in HackAtom India, and how do you see Cosmos ecosystem growing in India?
Yeah, actually, since we are together working since 2.5 years back, 2.5 years back, initially in 2018, nobody actually knows what Cosmos is. From now, everybody will try to build their application on Cosmos because this is this is more interoperable between many chains. So we also have an experience with Ethereum, Cosmos, Hyperledger, and Polkadot, etc. But we choose the Cosmos network because it is very interesting and the project structure is also very nice. All these parameters are very nice. That's why we developed on this, and we hope Cosmos is really uh, grown in future well.
Thank you, Prashant, for your encouragement. Now, I would like to hand over the mic to Akshay, who is from Team Interstellar. They have made a dynamic Instagram filter for Cosmos, and they have won the Community Award in HackAtom India. So now I would like to just call upon Prashant for his presentation. Sorry, Akshay, for the presentation.
Hello, am I audible?
Yes, you are audible, Akshay.
And is my screen visible?
Yes, it is.
Okay. So hello everyone. So my name is Akshay and I'm from Team Interstellar. So I've been affiliated with Cosmos, like I know about them since about a year, and I got to know them at a community engagement like event in my college, and that's how the journey began. I got interested in Cosmos in my final year project. Like I just graduated last year. So in the past 6 months of my final year project, I built a degree verification system upon Cosmos, and it had possibilities of taking it further, but it did not land up anywhere else. In when the hackathon idea came out, I was very eager to participate and I was looking for participants and all. But due to some time constraints or something, I could not develop a full application for it. So Abhitesh had been around and I've been interacting with him, and the community is an important part, and I wanted to try something in that segment. So instead of building a project for this hackathon, I tried to do the community engagement part. And to be true, like I was very bad at memes. Like I don't consider myself like a meme lord or something, but I just wanted to give it a shot. And I'll just take you through a few memes which I initially started with to create the engagement. So for it, like I created small memes like, did I hear about Hackathon India, about around the prize money, about the students and the online classes scenario, since we were all in the COVID-19 situation and all. Then there were others that Leonardo DiCaprio and the Starport workshop which took place and everything. Uh, so these were small boosters for everyone to like just grab attention towards Hackathon India and its value. When I completed the submission, the last meme was not at all planned. But when I myself submitted it for this, like my presentation or my work, at that time it came to my idea and then I created that. So this is how I started sharing it on Twitter to create engagement and to grab attention of people to help them participate and all. And it received a very good like response on Twitter and etc. After this, like simultaneously, I was building something on the sorts of an Instagram filter, and that was because I like memes and all help, but I wanted to create something which adds value and which can help spread the knowledge of Cosmos and its like small intricacies or details, because everyone to know about this technology, it's really important to spread the knowledge itself. So you can try it out right now. It is live. You can go to the Cosmos India underscore channel on Instagram and try it out right now. So to talk about it, it is designed slightly as a quiz and a game theory. Like you get a random question once you start the camera, and it asks you a small question on the Cosmos ecosystem, like the icon, does it represent Tendermint or the Starport or something else? Small, like how many validators are there? What is the coin called? Atom, etc. So it began like that, and then I started adding voice to it. I started adding a timer to it, and it slowly developed into really good things. I was really fortunate enough that during the HackAtom, I just could message a Bitage, or even for that sake, I had messaged in the Cosmos International group that I need some help with some quiz questions, and I got in touch with Cat.fish, which is like a huge thing for me. And she just DM'd or we just had a small chat, and I just showed her all the questions which I was planning, and she proofread them and he gave me a green signal. So these small interactions were really huge for me during the process of building this filter. And the response it represent like got was really amazing. When we launched the filter, everyone started sharing it on Twitter. And one of the most amazing feelings that when we launched the filter the next day, my phones are buzzing, and every time it was a tweet from a different language. One was from Croatia, one was from Philippines, one was from China, and various other Arabic languages, and so many Cosmos communities sharing this small filter. It really brought that sense of what Cosmos is. And for me, Cosmos at its core, along with its technology, is also the people that are the part of the community. And I'm really glad that I could contribute this small thing in terms of the community engagement. So I'll just show you a small demo. So this is the filter. So it asks you a question and gives you 5 seconds, and then you can answer it. So this is a small demo of it. You can go right now at Cosmos India Instagram handle and try it now. Try it now. It's Cosmos India _. Thank you.
Thank you, Akshay, for your presentation. I tried your filter a few times and I had a lot of fun using it. Many people in our community have used it, and I hear now and then about your filter. So, I just wanted to ask that how was your experience at HackAtom India, and how do you see Cosmos ecosystem growing in India?
For me, the experience at HackAtom India, like I was initially a part of like in touch with Cosmos and the community with Abhidesh and everyone. At HackAtom India, these are small initiatives which will help create the buzz around Cosmos and expand the ecosystem. And personally, for me at HackAtom India, the opportunity to interact with people, even Cat.fish just took out 2 minutes to proofread the question, but that was itself was like that small thing made my day. And those small interactions will help spread the community and interact and grow. And I was really grateful that the people are so helpful all around Cosmos, the community, even the international one, not only India. And in India, especially Sai Krishna, then Abhitej, and the whole group. So it was an amazing experience.
Thanks for the encouragement, Akshay. We will always look forward to providing value to our community and people. So, thank you so much, Akshay, for your
Thanks a lot.
presentation.
Thanks a lot, man.
Um, Thank you, everyone. Thank you, all the winners. It was a great session, and I hope that our community has learned a lot of stuff with your presentations. And now I would like to conclude by saying that just encourage more people to come into our community and get their hands onto Cosmos. And we will see you next time. Thank you. Bye bye.